Hello guys, and welcome to another video. We have remove nth node for end of list. So you're given the head of a linked list and you want to remove the nth node from the end of the list and return its head. You have an example linked list over here, 1, 2, 3, 4, 5, and because n is equal to 2, we want to remove this value 4 over here and return the linked list without it. In another scenario, we have a linked list which is the value 1, where n is equal to 1. We want to return null because we're going to have to remove that element from the very end, which is just itself. And for this one, you're going to have to remove the elements 2 as well. So you have 1 as your final value. Now, one way that you could do this would be by first reversing the linked list, and then from that end of the linked list, what you could do is count up to n amount before you basically remove that value and then return the linked list at the very end. The problem with that though is reversing the linked list takes multiple steps, and it's a little bit complicated because you'd have to convert it back into its original form afterward. And yeah, like this follow-up over here says, can you do this in one pass? Doing it through reversal of a linked list wouldn't be one pass because you'd have to iterate through it multiple times. So another way that we could do this is using 2 pointers. So what we could do, let's say we have 1, 2, 3, 4, and 5 over here. What we could do is we could have a pointer, let's say 2 pointers, left and right. Left can start off, let's say like at the very beginning over here, whereas the right one can be n away from the left one. So let's say like n is equal to like 2, it'll be 2 away. So it'll be, let's say like 1 and then 2. So distance is 2 away, and from here what we can do is, since we know that it's n away, we can effectively iterate through move the pointers forward on the linked list, right? Up until r is empty. So once you do this, you realize, oh, okay, like the next one value for r is going to be nothing, and at this value, well, we know since it's n away, we know at the left pointer that's the value that we have to remove. From there, we can remove it by setting the previous element's next one from 4 to 5. So if you notice, you can't, given like a pointer to a certain element in a linked list, you can't just remove the element because you'd have to refer to its previous and set its previous next pointer, the next value, to the one after 4. So in order for us to be able to do this, what we have to do is we have to go from one step back, and then we can do this by creating a dummy node, which it can point to initially. So to explain this in a little bit more detail, we have the basically the right pointer over here, the left pointer over here, and it starts off at like a dummy node, let's say like 0. We can create that dummy node over here, and then we can have that point to the very first value in that linked list. And then from there, we start off like as usual, we move the pointer an amount, right? So we go like move like that, all the way up to the ends, except at this point, eventually you reach the value over here, right? Because you're pointing at the dummy one and you're hitting 3, 4, 5. What you can do now is refer to this one and make that one's next value equal to that one. So we can make 3's dot next value to 5 and effectively remove this in the linked list. But we have to have some sort of dummy node first in order to basically have it go behind by that amount. So if we go ahead and implement this now, what we can do is we can set the left pointer, we can instantiate a left pointer to equal, well, yeah, okay, so we can create a dummy list node like we were talking about. So we'll have like list node dummy over here with the value 0, and then we have the value over here, and we want the next one to be pointing to the head. And then we want the right value to be pointing to, the head. From here, what we have to do, well, we have to get r to be n ahead of the left one, right? So what we actually have to do is we can do while n is greater than 0. We can iterate the right pointer forward. So we'll do basically r.next, or r equals r.next, and we can subtract n by 1 up until it's equal to 0, whereupon it'll be n ahead of l. After we do that, what we can then do is iterate both pointers forward. So while the right pointer exists forward, while right exists, what we can do is iterate the left to equal left.next and r to equal r.next. And then at the very end, we'll know that when it hits a dummy one, that's when the left pointer is going to be at this specific position, whereupon we can then set the value of the left pointer, l.next, equal l.next.next, effectively skipping the element that we're trying to remove. If we go ahead and return the final value, which is just a head again, so we can go ahead and do that by basically returning the head, which is just l left dot next, because it's set to the, oh, sorry, not left, right, okay. Oh, actually, let's change this by setting this value to a list node over here, having a dummy pointer, and then having it set to dummy initially. But dummy will stay the same, so what we can do is return dummy's next value, which is going to be head, in order to have the final value. So if we go ahead and run this now, okay, accepted all test cases, and if we go ahead and submit, nice, fully accepted. So the time complexity of this would be O of n, and you'd only be passing through every single element in the linked list once, which is fulfilling the follow-up question over here. The space complexity would be O of 1 because you're not actually storing any values in the linked list in like an array or something of that sort. So yeah.